Hello and welcome to part 2 of lesson number 4 in Unit 0 Algebraic Tools in our grade 11 University College math class. This is the third and final day of factoring where we look at special cases, including difference of squares and perfect square trinomials. The first part of this video we did the difference of squares and we worked through it. We're now going to be looking on the second page at sort of the complement to that, which is perfect square trinomials. And as before, we're going to start with a bit of a definition. A perfect square trinomial means that we have two identical binomials being expanded out to give you this particular result. Now, obviously, it looks a little bit different when it gets expanded out, but we have two of these guys. So let's just start here on the far side because we're already over here. Let's do a rewrite and expand this out so that we can see what a perfect square trinomial looks like and hopefully how to identify it. So let's do some expanding. We have 3x times 3x, that gives us 9x squared. 3x times minus 5 is minus 15xy. 5y times 3x minus 15xy. And lastly, minus 5y times minus 5y is plus 25y squared. Let's gather together the terms that are alike. What you'll notice this time is that unlike difference of squares, where these middle terms undid each other and there was no middle term, this time we actually have two identical ones. So when we combine them, it's like you have sort of like 2 times that 15, or in this case, 30 xy's plus, oh, I forgot a 5 over there. Get in there, you. 25y squared. There we go. So again, as I always say when we're doing this particular type of thing, remember what we're looking for here is patterning. What about this leads you back to here? What about this leads you back to here? Right now we're working from a set of binomials down to a trinomial. Ultimately we're going to be working back this way. How could we get from the trinomial back to two sets of identical binomials? Let's finish up the expanding and then we'll see if we can spot a pattern. And I'd like to say right now that if you never quite get this perfect square trinomial thing figured out, it's totally okay. You can always factor the resulting trinomials like tricky tries or simple tries and there'll be no problem. You'll definitely get there. This is sort of a shortcut if you're inclined that way. So let's rewrite this. 2x plus 5, 2x plus 5, and expand away. So 2x times 2x is 4x squared. 2x times plus 5 plus 10x. Same thing again, plus 10x and plus 25. Let's gather together those like terms. Again, there are basically two of them, so it's like having 2 times one of them, which in this case is going to be plus 20x's and plus 25. So again, what do we notice from where we start, which is down here, 4x squared? What leads us back up to the top? Plus 25, what leads us back to where we started? That's definitely the piece that we want to be considering, knowing that we're ultimately going to be heading from the trinomial back to the binomials. And one more example, just so we get the full picture. This one's probably the easiest one here, at least the easiest one to see. There's our x plus 7 and our x plus 7. Let's expand it out. We've got an x squared plus 7x plus another 7x and plus 49. Let's gather together those two terms that are alike. We have x squared plus 14x, which is kind of 2 7s, and then plus 49. So again, as I've been saying, what about this term leads us back to the beginning? What about this term leads us back to the beginning? How, if we were given this trinomial, could we work our way back to those two binomials? So here's the thing. Like I said, this one's a little bit more complicated. It's maybe obvious that we've got these trinomials down here. It starts with a perfect square. It ends with a perfect square. And those are so the square root of each of those terms is the first and second terms you see in the brackets here. However, the middle term, this 14x, is the tricky piece for people to recognize. It is actually, so if we do this, so the square root of x squared is x, and the square root of 49 is 7, and 7 times x is 7x. If we were to multiply that by 2, which is sort of a version of this like doubling that we have right here when we expand it out, we end up with 14x, and that is indeed our middle value. So this becomes part of our system of figuring out, hey, is this trinomial a perfect square trinomial? If it is, you'll have here a square root times the square root. Multiply that result by 2, and if you end up with the middle term, you'll know it's a perfect square trinomial. As I said, it's a bit of a long process. Let's jump down and try a few examples, and we'll see if this patterning makes sense to you or not. Again, up here we just have a little bit of a sort of as an algebraic version of what we just talked about, but let's just jump right into our first example. It's been filled out, so if you want to copy it down, that's great. We have x squared minus 6x plus 9. So is this a perfect square trinomial? It looks like it. We have a perfect square here in x, oops, let's get a highlighter. We have a perfect square here in x squared, a perfect square here in 9, but we need to identify whether that middle term is indeed the result of the perfect square. So we take the square root of the first term, that's x, square root of the final term, that's 3, multiply them together and times it by 2. That gives us our 6x, and 6x is indeed our middle term, which means that what goes into our brackets are the x and the 3, check and check. Now, the sign we haven't talked about yet. The sign is exclusively the domain of whatever's happening with our b value. So because this is a subtract 6x, this is going to be a subtract 3. The last value, this one here, the plus 9, will always be positive because whether the two numbers you're multiplying together are both positive or both negative, the result will always be positive. So that's no big deal. All right, there's our first example. Let's try another one and see how we do here. So we have 25y squared plus 20y plus 4. Is this a perfect square trinomial? Let's figure it out. So in order to figure it out, we take the square root of the first term. So 25y squared will give us 5y. Square root of the last term, that's 4, gives us a 2. Now if we multiply these together, so 5y times 2, and then we double it, we should end up with this middle term right here, if this is a perfect square trinomial. So 5y times 2 is 10y, times 2 equals indeed 20y, which is our middle term. So we've hit all the criteria here. We've got these two guys leading to double this in the middle, so we are going to create ourselves a set of brackets, or two sets of brackets, I guess. So, two sets of brackets. Because we start with our 5y squared, or our 25y squared, each bracket is going to start with a 5y. We close out with a 4, so these are going to end with 2's. And now, what's the sign going to be? Well, the sign on our b value is a plus, which means that each of these is a plus. And then we do a final rewrite, just the binomial, all squared. There it is. There's our second example. And again, I know this is a little bit convoluted and difficult, and if you can just do it like a tricky trinomial and that works for you, like I said, fill your boots, don't beat your head against the wall on this. No problem at all. One more example. Okay, here we go. We've got here a potential perfect square trinomial. However, I know that 2 is not a perfect square, which leads me to believe that there is a common factor here, and I can see it. It is going to be 2. Which is going to leave us with v squared minus 8v plus 16. Now, is this a perfect square trinomial? Possibly. We have two perfect squares right there, so let's dig in and see. We'll try by taking the square root of the first term, which is v, square root of the last term, which is 4, and if those two times each other and then doubled gives us the middle term, then we're in business. So 4v obviously is just 4v times 2 is going to give us 8v, and that is indeed our middle term. So we have found a perfect square trinomial. We're going to be using these values over here. This one was our tester. So again, that 2 has to come down with us. There's the 2, bracket, 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 bracket. So because we started with a v squared, each bracket will start with a v. Because we concluded with a 16, each bracket is going to end with a 4. And what's that sign going to be? Well, if we look at our b value, it is negative, which means that each of these will be negative as well. Lastly, a rewrite step expressing those two identical binomials as a single binomial squared. And that's it. Those are, whoa, got out of the way there, perfect square trinomials and difference of squares. Good luck with the homework again. Like I said, in this last part, you can always treat them like tricky trinomials if the procedure just seems like a bit much. But good luck with the homework. If you have any troubles, reach out as always via email, in person, or by logging into our classroom video chat that's open every day. Good luck with this homework. One more lesson to go. We'll see you in lesson number 5.